Continuing lesson 2.6, apply proportional reasoning. If we look at the do you know how number 4, this is on page 124. So a recipe calls for 15 ounces of flour for every 8 ounces of milk. And the question, part A, is the relationship between the ounces of flour and ounces of milk proportional? When they list it this way, when it says ounces of flour and ounces of milk, usually what that means is we'll do the flour first and then the milk. So 15 over 8. And this is kind of like the y over x that we've talked about as far as things being proportional. And this is going to be a consistent pattern. Every 15 ounces of flour, we have 8 ounces of milk. So in other words, if we added this again, added another 15 ounces of flour, that'd be 30 ounces for another 8 ounces of milk would make 16 ounces of milk. And then that would reduce down to 15/8 as well. So no matter what we have here, yes, these would be proportional. Basically, for an explanation here, we could say we have a ratio of 15 over 8 between flour and milk, no matter how much we have. Another way we could talk about this would be, we've talked about equations like y equals kx or y equals mx. Constant of proportionality, or our slope here, would be 15/8. So we could say, yes, we could use the equation y equals 15/8 x. And you could find points on that line. That would always be proportional. Part B, if you use 15 ounces of milk, how much flour should you use? So 15 ounces of milk. Now understand what we did up here. That ended up being 16 ounces of milk. So it's not exactly an even amount for us just to add on something. So one way you can do this, probably the easiest way, is just to substitute. We're looking for how much flour we would use. So we're trying to figure out what y is if we have 15 ounces of milk. So 15 ounces of milk, what that means is that x is equal to 15. 15 we could write as 15 over 1. And then we could multiply that. So 15 times 15 is 225. 8 times 1 is 8. So 225 divided by 8, you can divide that out. Change it to a mixed number. That would be 28 1/8 ounces. Okay, again, preference for a mixed number answer, not a decimal there. Looking at workbook page 31, number 1, table shows the number of calories Jane burns while exercising. How many calories would she burn by exercising for 29 minutes? And explain. The first thing we would probably want to do here, we've talked about proportional as being y divided by x. So if you look at the first numbers they've given us, 220 calories burned in 20 minutes. So if you take 220 divided by 20, you'll get 11. We need to actually make sure and verify that this is actually proportional before we can go any further. So what we would really want to do actually next is take 275 divided by 25, which is 11. 330 divided by 30 is 11. 440 divided by 40 is 11. Okay? Since all of those came out the same, we know it's proportional. Now we know we can use our proportional reasoning in order to work this out. So when we got 11s for all those, we know that means it's 11 calories burned per minute. Okay, so 11 calories burned per minute, and we're going for 29 minutes. So you could then take 11 times 29, which is 319 calories burned in 29 minutes. There are a couple of other options you have. One option somebody in one of the classes mentioned is that on our table, we know in 30 minutes it was 330 calories. So 11 calories a minute. If you just take off a minute, take off 11 calories, 330 minus 11 would be 319, which is actually quite a bit easier if you're working it out by hand, especially not to have to multiply 29 times 11. 330 minus 11 would be an easier problem. Okay, or you could go up from 25 minutes. Go up 4 more minutes. So 4 minutes would be an additional 44 calories burned. So 275 plus 44 would also get you to that answer. Okay, but again, we want to verify first that it is proportional before we actually go any further and make our prediction here. Number 3, at a cookout, Mrs. Crawford makes 8/9 of a pound of chicken plus 1 pound for each guest. Is the relationship between the number of guests and the pounds of chicken proportional? And explain. Alright, so if we look at this, we can kind of think about what's happening. One thing you might think about, like we've been talking about, is, do we have a y divided by x? That's going to be the same. And before we do that, really, we need to decide what our x and y are going to be. So you could think about either we could have pounds of chicken per guest, or we could have guests per pound of chicken. Pounds of chicken per guest seems to make more sense. So pounds of chicken would be like our y, and the guests would be like our x. That way when we do y divided by x, we're doing chicken per guest, okay? And you might think about starting out is that 8/9 pound of chicken plus 1 pound for each guest. So you might think about, if we have one guest, how much chicken are we going to have? Well, 8/9 of a pound plus 1 pound, so that'd be 1 8/9 pounds for one guest. For 2 guests, we're going to make another pound. So 1 8/9 plus another pound would be 2 8/9, and so on. One observation you could make would be actually that if we have no guests, we would have 8/9 of a pound. If you make that observation, you might be able to think about, remember, proportional relationship goes through the point 0, 0. And so that would be one way to come up with that. It's not going to be proportional. It's not going through 0, 0. It's going through 0, 8/9. Another way we could do this is actually do our y divided by x. So 1 8/9 divided by 1, which would be 1 8/9. Okay, 1 8/9 pounds per guest if we had one guest. If we have 2 guests, we could do 2 8/9 divided by 2. That one we would have a little bit more working out to do. We would have to think about 2 8/9 divided by 2. So that's 26/9 divided by 2 over 1. Change reciprocal. That's 26 over 18, which is 1 8/18, or you can reduce that to 1 4/9. So if that's 1 4/9 pounds per guest, and if we had one guest, it was 1 8/9 pounds per guest. Obviously, that's not the same. This kind of goes back to what we were talking about with ages. You're adding 1 year to each of these things. It's not proportional. So rather than working that all out, if you didn't see, if you didn't see the 0 8/9, another thing you could do is think about that we're adding up 1 guest and 1 pound. When you take a fraction and you add to the numerator and denominator, you're not going to get an equivalent fraction like we talked about, okay? Remember, to get equivalent fractions, we have to be multiplying or dividing. So that would be another way we could tell that this is not going to be proportional. Number 5, a machine can make 56 parts in 4 hours. Again, be highlighting as you read through these. Makes it easier to work it out. Can also make 70 parts in 5 hours. Write an equation that relates the number of parts the machine can make and the time in hours. And then predict how many parts the machine can make in 9 hours 30 minutes. So before we can write an equation, we need to figure out our unit rate. Before we find our unit rate, really, as we're doing that, we need to make sure that this is proportional. So parts per hour sounds good. So if we do 56 divided by 4 is 14 parts per hour. And then we can verify 70 divided by 5 also is 14. So that's good. That means it's proportional. That means we can write our equation here with what we know. So our equation normally is like y equals kx or y equals mx. So y equals 14x could be your equation. If you wanted to use like p for parts and h for hours, you could do that also. So you could say like p equals 14h would be another equation that you could have used if you used different variables. So to predict this for 9 hours 30 minutes, I should say. 30 minutes is half an hour. 9.5, that's the same as 9.5. So one option is we could put 9.5 in place of our x in our equation. And that would be 133 parts in 9.5 hours. Another option some people were talking about is find it for 9 hours, so 14 times 9, get that answer, and then you could say 30 minutes is half an hour, so if they produce 14 parts per hour, in a half hour they would produce 7 parts. So take the 9 hours plus the 7 parts for that half hour, and then that would give you 133 also. Number 8, the table shows the numbers of home runs a baseball player hit during spring training and during the regular season for 4 years. How many home runs would the player likely have hit during the regular season with 3 home runs during spring training? So if we had 3 home runs during spring training, the question is how many home runs during the regular season? Okay, so if we look at the information on the table here, like we've been doing, probably a good starting point would be take the y divided by x. In this case, it doesn't have to be a certain way, but you might find it easier to take 8 divided by 2. 2 divided by 8 is going to be a fraction less than 1. So 8 divided by 2 is 4. Next, we've got 4 divided by 4 is 1, and we've got a bit of a problem. 20 divided by 5 is 4. 24 divided by 6 is 4. Okay, so we have one little blip here that was not the same as these other ones. With that being the case, you could say that it's not proportional, and so we are not going to be able to make a prediction here. Okay, that would be one argument, and I would accept that answer. Another argument you could make is that there's only one time that happened. The rest of the time, we always had a ratio of 4 to 1. So you could say, you know, if we had 3 in spring training, okay, that's always 4 times as much, except for this one here, this oddball. Okay, and so that would represent 12 home runs during the regular season. Okay. If you did that, you'd need to at least show that you understand that it didn't always come out the same, all right? Because, you know, obviously if somebody just did 8 divided by 2 is 4, they didn't look at any of the other numbers, and then they did 3 times 4 is 12. You know, you have to show me that you understand that you understand that it didn't always come out that way. Or like I said, you could just say it's not proportional and that we're not going to be able to make that prediction. Okay, so this gives you an idea of how to apply proportional reasoning.